Okay. Hello, grade 12, grade 11. This topic that I will be looking here, hyperbola function, is suitable for grade 11, grade 12 mathematics students. So if you are doing math 11, 12, this is for you. You are welcome to Academic World by Mpatele TL. In today's topic, we are looking at a hyperbola function. Hyperbola function. So without waste of time, let's go through it. We are talking about the function of this form. The function of the form f of x equals to a over x minus p plus q. What you have to see there, spot very carefully, is that the variable x is the denominator. So whenever x is underneath on the fraction, whenever x is the denominator, you know that we are dealing with a hyperbola function. So hyperbola functions are in this form. For now, we did not show the value of a, p, and q, but we know a, p, and q are the real numbers. So let me do this. A, P, and Q are the elements of real numbers. So we are going to meet different hyperbola functions where A, P, and Q are numbers. Let me give an example of what I'm talking about. F of x equals to 4 over x minus 3 plus 6. So we know that A is 4, P is 3, Q is 6. A is 4, P is 3, Q is 6. So A, P, Q are the real numbers. But if we go further, the A, there is an information which we can get from A, this A here. So whenever A is greater than 0, whenever we are going to sketch the graph, our graph is going to be in the first and in the third quadrant. I will still explain it as we go on with our maths. For now, just know when a is greater than 0, the graph is going to be in the first and third quadrant. Don't worry, I will explain it better. Now, P and Q, they represent our asymptote. That's where we are going to find our asymptote. The hyperbola function has got what we call the x asymptote and the y asymptote. I will still explain these ideas. Don't worry. Just relax and enjoy your maths. P denotes x asymptote, Q denotes y asymptote. I talked about it. P and Q will be representing our asymptote. X and f of x denotes any point on the function. This one, guys, is a very important mathematical idea. Let me just explain it here. Let's say you have a graph, which is a hyperbola graph. Let's say you have the y-axis, the x-axis. I prefer to use black, yes. Let's say you have the y-axis, x-axis, and you have a graph. It's a hyperbola graph, and on the hyperbola graph there is a point. Let's say you have a point here, point A, perhaps is 2 and 5. So what we are saying is that this x that you see and this y that you see on this equation, f of x equals to a over x minus p plus q. Remember, this f of x actually represents y. So this x and this y can be substituted by any point on the graph. So you have a right to say, okay, my f of x is 5. You can substitute y with 5. You can substitute x with 2. So normally this idea works if you want to solve for A. This A here on top, sometimes you will be required to calculate the value of A. So you will have to substitute x, and this f of x by any point which lies on this hyperbola graph. You go to any point which is found on the graph, you substitute x and y. So that's why I'm saying x and f of x, which is y, denote any point on the function, any point on your graph. Most of these things I will still explain them. Okay. A can be used to determine the quadrant in which the graph lies. Okay, we'll talk about it. The domain and the range of the hyperbola. We'll talk about the domain and the range immediately after sketching the graph. I'll explain what is the domain of the hyperbola, what is the range of the hyperbola. Sketching of a hyperbola function. So I want us now to sketch. To sketch means to draw. Give us what we are saying. We're saying we want a picture that represents a hyperbola function. Show this hyperbola function in terms of a graph. So we are going to sketch a hyperbola function. For now, we are going to sketch this one. F of x equals to 4 over x minus 3 plus 2. This is the hyperbola function I want us to sketch. So what are we doing? We are representing it in terms of a graph. So my first step, I said, step 1, I said, determine x-intercept. Okay, by letting y to be 0. This one needs to be explained now. When we are sketching a function, okay, here I don't care which function you are sketching. Hyperbola, quadratic, cubic, exponential, straight line, whatever graph you are sketching. Whenever you are sketching a function, please find your intercept. So you must find intercept. You must find the x-intercept. Why actually do we have to find the x-intercept when we sketch the graph? We must back up everything that we are doing with reason. Why do we have to find the x-intercept? Okay, I'm sketching a hyperbola function. Y exists, x exists. I'm sketching a hyperbola function, and I know that this hyperbola function might pass through the x-axis. So let's say we've got 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. I know that the hyperbola function might pass through the x-axis. So I have to know at which point does the hyperbola function pass at the x-axis. At which value of x does the hyperbola function pass at the x-axis? Actually, the x-intercept can be called the x-cut of the graph. At which value of x will the graph pass? Will the graph pass here, where x is 1? Will the graph pass here, where x is 2? Will the graph pass where x is 3? Where will the graph pass? At the x-axis. So I have to find the x-intercept. And at every, okay, this one also is important, pay attention. At all the points on the x-axis, the value of y is 0. So let's say we are here at this point. I'm trying to show the point so that it can be visible. This point is exactly on the x-axis. So the value of y here is 0. Actually, it means the coordinates of this point is minus 4 and 0. So at Okay. English, I have to come down and explain my ideas. Let me get more water. At every point on the x-axis, whether you are at the point where x is 2, whether you are at the point where x is negative 3, at all the points on the x-axis, you know that the y coordinate there is 0. So it means the coordinates of this point is 2 and 0. As long as the point lies on the x-axis, and the point that lies on the x-axis actually, you can consider it the x-intercept. So at all the points on the x-axis, the value of y is 0. So that is why when we are looking for the x-intercept, we let y to be 0. So we are going to look for the x-intercept of this function. How are we going to find the x-intercept of this function? By letting y to be 0. Why do we let y to be 0 when we are looking for the x-intercept? Because we know that at the x-intercept, y is always 0. At all the points on the x-axis, y is always 0. So I'm going to erase here. Let me erase. I was just showing this one for explanatory purpose. Now, so you can see what I've done here. I said we are determining the x-intercept by letting y to be 0. We are determining the x-intercept by letting y to be 0. So you can see f of x, which is my y, is now 0. So I have 0 equals to, 4 over x minus 3 plus 2. Now, one thing for sure, as I continue, I'm going to solve for x there. 0 equals to 4 over x minus 3 plus 2. I'm going to solve for x. Now, in maths, if you have an opportunity of grouping like terms, if you see possible like terms, please group the like terms together. Add those like terms or whether you subtract them, depending on the operation. So I see that 0 and positive 2 are the like terms. So I'm going to take positive 2 to this side. I'm transposing positive 2, so it's going to become negative 2 when it goes to the left side of equal sign. So minus 2 equals to 4 over x minus 3. Now, okay, when I'm solving for x in an equation, I don't like denominators. So you see that you have got 4 over denominator x minus 3. So when I'm solving for a mathematical equation, I want to remove the denominator. So what I'm going to do here, I'm going to say, remember it's minus 2, it's minus 2 equals to 4 over x minus 3. So I want to remove this guy, x minus 3. How? I will multiply by x minus 3 on the right. I know that this multiplication of x minus 3 is going to cancel the x minus 3 underneath. So on the right, I multiplied by x minus 3. And mathematically, we say, what you do on the right, you must also do on the left. If you are multiplying by x minus 3 on the right, also multiply by x minus 3 on the left side of the equal sign. So you will have, you see, after x minus 3 cancelling x minus 3, you are left with 4. So you will have 4. Now on the left side, you have minus 2, which is also multiplied by x minus 3. Or one can say, let me do cross multiply. Remember, underneath minus 2 is the same as underneath minus 2, there is invisible denominator y. So you can say, okay, let me do cross multiply. Minus 2 times x minus 3. which becomes minus 2 into x minus 3. Then you say 1 times 4, so which is equal to 4. So you can still say cross multiply, but I prefer the idea of saying I multiply by x minus 3 both sides to remove the denominator. Now you see that you have minus 2 into x minus 3. You are multiplying negative 2 with x minus 3. Don't forget distributive law. When you're solving for variables, when you're solving equations, do not forget distributive law. Distributive law says the number outside the bracket multiply every number inside the bracket. So you say negative 2 times x is negative 2x. Negative 2 times negative 3, which is going to give you positive 6. You multiply throughout by negative 2. You are using distributive law. Yes. Minus, can I pick a highlight? Okay, a different color of it. So you say minus 2 times x is minus 2x. Minus 2 times minus 3 is positive 6. So minus 2x plus 6 equals to 4. Now what are you going to do from here? You are going to group like terms. You are going to take positive 6 to this side. So you will have minus 2x equals to 4 minus 6. Minus 2x equals to 4 minus 6. 4 minus 6 is minus 2. Minus 2x equals to minus 2. Now you divide both sides by minus 2. X is 1. X is 1. So this is your x-intercept. So your graph will cut the x-axis at 1. Now after finding the x-intercept, we need to look for the y-intercept. This is very important when we sketch the graph. We have to find our x-intercept and also find our y-intercept. Let's go for the y-intercept. Y-intercept, let x be 0. So when you are looking for the y-intercept, you let x to be 0. And what is the y-intercept? Why do we have to find the y-intercept? I normally define the y-intercept as the y-cut of the graph. Is that value of y where the graph will pass? Maybe the graph will pass at the value where y is 2. Maybe it's 3. Maybe it's 4. I have to find the y-intercept. I have to know where on the y-axis. Let's say you have the y-axis like this one. And you have the x-axis. Where on the y-axis will the graph pass through? So I will need to find the y-intercept, which is the y-cut of the graph. And at any point on the y-axis, at all the points, at any point on the y-axis, the x-coordinate is 0. So if I were to put a point on the y-axis, let me just put a point maybe here. Let me just put it here. Okay. So what are the coordinates of this point? What is the x-coordinate? What is the y-coordinate? The x-coordinate, it is 0. Why am I saying the x-coordinate is 0? Because we are talking about a point on the y-axis. The coordinate, the x-coordinate of a point on the y-axis is 0. So the y, I don't know it actually here. It might be 0.5, but what I wanted to emphasize is that on the y-axis, all the points that are found on the y-axis, their x-coordinate is 0. Even if I put the point here on the y-axis, the x-coordinate is going to be 0. The y-coordinate is minus 2. So that is why we say when we are looking for the y-intercept, we let x to be 0. So that's what I've done. This is my f of x equals to 4 over x minus 3 plus 2. Let's come with it here. You see that where there is x, I've substituted x with 0. X here I've substituted with 0. So where there is x, I put 0. When I'm looking for the y-intercept, where I see x, I put 0. So I'm having f into 0 equals to 4 over 0 minus 3 plus 2. So what is 4 over 0 minus 3 plus? Here just press your calculator now. Just say 4 divided by minus 3 plus 2. You'll get 0.67. You'll get 2 over 3. The y-intercept is 2 over 3, which is 0.67. Let's just also write it in a decimal form. It's 0.666 recurring. So I'm rounding to 2 decimal place, 0.67. So I found the y-intercept. And I also found the x-intercept. So it's very important when you are sketching the hyperbola function to find your intercept, the x-intercept and the y-intercept. Now what I'm going to do, I'm going to find the asymptote. So I said that is my step 2. My first step was finding the intercept. Now my second step is to find the asymptote. The hyperbola function has got what we call the asymptote, the x-asymptote and the y-asymptote. Let me erase and explain what are these asymptotes. What are we talking about when we talk about the asymptote? So I'm saying the hyperbola function has got the asymptote, because it's more than one. There are two extras. So I will say we have got what we call the x-asymptote. What is this x-asymptote? The x-asymptote is the x value whereby the function is undefined. It is the x value whereby the function is undefined, meaning that for that specific value of x, your function is not defined. And for that specific value of x, you cannot be able to find the value of y. So I'm going to pick two values of x here. I'm going to say, let us put our focus on x equals to 1 and also on x equals to 3. Let's ask ourselves this question. When x is equals to 1, what is the value of y? Which value of y does x being 1 relate to, map to? So I'm going to say, okay, I'm coming to this equation, f of x equals to 4 over x minus 3 plus 2. I'm going to look for y. Remember, this f of x actually represents y. So I'm going to say y equals to 4 over, where there is x now, I'm putting 1. 1 minus 3 plus 2. So what is the value of y when x is 1? You can press your calculator. 4 divided by 1 minus 3 plus 2. 4 divided by negative 2, negative 2 plus 2, it's 0. So y equals to 0. So when x is 1, y is 0. But what about when x is 3? What is the value of y? So we're going to say y equals to 4 over, where there is x now, we put 3. So we say 3 minus 3 plus 2. Y equals to, press your calculator. What is the value of y? Math error. If you are using Casio, say it's math error. The value, in this case, we are not able to find the value of y. So we are saying when x is equals to 3, function is undefined. We cannot be able to compute y. We cannot be able to calculate y when x is free. We don't know the value of the, actually, when x is free, there is no value of y that exists there. The function is undefined. So we say x being free is the x asymptote. What is the x asymptote? That value of x whereby the function is undefined. The function in this case is undefined when x is equals to free. So x being free is the x asymptote. Hopefully that makes sense. So when x is free, we cannot find y. Actually, the hyperbola function will not pass, in this case, this graph f of x, will not pass at any point where x is free. This x asymptote will be shown on a Cartesian plane with a dotted line. Let me show you how do we show the x asymptote on a Cartesian plane. Let me erase. I'm going to put my plane here. I want to put my plane here. So I have the y-axis, I have the x-axis, and what is the x asymptote? Free. 1, 2, 3. This is where we find the x asymptote when x is free. This x asymptote is going to be shown by a dotted line. So next near to this free, I'm going to put a dotted line. This is my x asymptote. You see that the x asymptote is represented by a vertical dotted line. So the x asymptote, it is also called the vertical asymptote. It is also called the vertical asymptote. So the x asymptote is the vertical asymptote. It is shown on a Cartesian plane by the dotted line. So every time on the graph, when you see a dotted line, you know that we are talking about the asymptote. Whenever it's a vertical dotted line, we are just talking about the x asymptote. It is the x asymptote because if you look at this dotted line, it's passing the x-axis when x is free. So it is the x asymptote. The vertical asymptote is the x asymptote. So now, how do we easily find this x asymptote? We always equate the denominator on our function. We equate the denominator to 0. X asymptote, you can see here I set x minus 3 equals to 0. I'm equating the denominator to 0. Where do I get this x minus 3? This x minus 3 is the denominator on the function f of x. It's 4 over x minus 3. So x minus 3 equals to 0. You say x minus 3 equals to 0. This is how you find the x asymptote. And what is the x asymptote? The x asymptote is equals to 3. You say x minus 3 equals to 0. You solve for x here. Minus 3 comes this side. X equals to 3. X equals to 3 is your x asymptote. That's the easy way of finding the x asymptote. You equate the denominator to 0. But why? Why? Why do we have to equate the denominator to 0 when we are looking for the x asymptote? We know that the function, this f of x, this function f, if x minus 3 is 0, it's going to be undefined. So what actually we are saying, whenever x minus 3 is equals to 0, f of x is undefined. Then we say, oh, the function is undefined when x is equals to 3. So you have the x asymptote. What is the x asymptote? the value of x where the function is anti-pi. What is the easy way of finding the x asymptote? By equating the denominator to 0. What more can we say about the x asymptote? The x asymptote actually shows the value of x where the graph cannot pass. The graph will not touch this dotted vertical line. The graph will not pass at any point where x is free. That was the x asymptote. The y asymptote is 2. If you look at this function, f of x equals to 4 over x minus 3 plus 2, the y asymptote is this number at the end here, positive 2. Positive 2 is your y asymptote. What do we mean actually here? When we say y asymptote, we are actually referring to that value of y which there is no value of x that can map to that value. So when y is 2, we cannot find any value of x that can give us the value of y being 2. So I'm going to explain this by picking two values of y. Let me pick two values of y. One value of y that I'm picking is the y asymptote. And what is the y asymptote? You still remember what is the y asymptote? The y asymptote is 2. This number at the end is your y asymptote. This number at the end is your y asymptote. So I'm saying when y is 2, I will try to find the value of x. And I will pick another value of y. Which value of y can I pick here? Okay. Any value of y, let me pick. Okay, let me not try to pick too much. Let me just pick any value of y. Let me pick 5 or 4 or 10. Let me pick 10. Let me say when y is equals to 10, what is the value of x? Now, I'm going to use y equals to 2, y equals to 10. You can continue. You can pick different value of y and try to find the value of x. I guarantee you, when y is 9, you will find the value of x. When y is 6, you will find the value of x. When y is 10, you will find the value of x. This is what I'm going to do with you. But when y is 2, you will fail to find the value of x. That is why we say, okay, for different values of y, we can be able to find the value of x, the input value. But when y is 2, we fail to find the value of x. So let's check. Let's say whether it's f of x, we put 10. 10, y is 10. What is the value of x? I will be quick here. Take 2 to the other side, 8. Cross multiply, 8x minus 26. I'm trying to be quick. Equals to 4. 8x equals to, you take minus 26 to this side, 4 plus 26 is 8. Divide by 8 both sides. So when y is 10, x is 30 over 8. You can simplify it further and take 15 over 4. So when y is 10, x is 15 over 4, or you can say 30 over 8. But when y is 2, what is the value of x? We will fail to find the value of x. Let me show you. When y is 2, we say 2 equals 2. Where is y I'm putting 2? I'm trying to find the value of x. Now take positive 2 to the left. 0 equals to 4 over x minus 3. If you do cross multiply, you have 0 equals to 4, which is wrong. 0 cannot be equal to 4. So when y is 2, we fail to find the value of x. meaning that there is no value of x that maps to y being 2. There is no relationship between a certain value of x and y being 2. So we say this y being 2 is the y asymptote. There is no value of x that can give us the value of y, which is 2. Okay. So we found the x asymptote by equating the denominator to 0. We found the y asymptote. We say this number here at the end is the y asymptote, which is 2. Now, before I even go to sketch the graph, in a hyperbola function, if they ask you what is the domain, what is the domain of this graph, of this function, you say x can be any number. X is the element of real numbers, but x should not be free. So what you are saying is that the function is defined for all values of x. For all values of x, for different values of x, you can be able to find the value of y, but whenever x is free, you cannot find the value of y. So you say x is the element of all real numbers. X can be any real number, but x should not be free. X should not be free. X can be any guy, any number, but x should not be free. That is the domain. Do you still remember the definition of a domain? A domain is the values of x whereby the function is defined. So this hyperbola function here is not defined when x is free. So x being free cannot be part of the domain. That is why we say the domain, x can be any real number, but x should not be free. So if they ask you the range of this hyperbola function, you say y is the element of real numbers. Y can be any real number, but y should not be 2. So, okay, so in a hyperbola function, if you know the asymptote, the x asymptote, you can be able to find the domain of that hyperbola function. You just say x can be any real number, but x should not be that x asymptote. X should not be free. There is a big relationship between the domain and the asymptote. There is a big relationship between the domain and the x asymptote. There is a big relationship between the range and the y asymptote. So let's say I give you the domain of a hyperbola function, and I say the domain, okay, let me see. And I say the domain, x is the element of real number, x is not negative 1. If I ask you to find the x asymptote, what's going to be the x asymptote? X equals to negative 1. So this is the domain. We usually call this the equation of the x asymptote. So if I give you the range, and I say y is the element of real numbers, and I say y should not be 6, and I ask you to find the equation of the y asymptote. What is the y asymptote? Sorry, y equals to 6. Okay, I was just explaining further about the relationship which exists between the x asymptote and the domain. The relationship which exists between the y asymptote and the range. Okay, remember the main concept that we are going through here is to sketch the graph. I have to sketch the graph with you. So I have found the x asymptote, it's free. I have found the y asymptote, it is 2. Now, it's very important to also show you the y asymptote on a Cartesian plane. 1, 2. So the y asymptote can be shown by a dotted vertical line. So a dotted vertical line will show you the y asymptote. What is the y asymptote? 2. So you go to 2, you show a dotted did I say the y asymptote is a vertical line? No, it's a horizontal line. So this is a dotted horizontal line is your y asymptote. A y asymptote is also called the horizontal asymptote. The horizontal asymptote. Yes. A dotted horizontal line is the y asymptote. The y asymptote is the horizontal asymptote. This is how you show it on the Cartesian plane. How do you show the asymptote on the Cartesian plane? By the dotted line. So now I think we are ready to sketch the graph. We know the intercept, the x-intercept and the y-intercept. We know the asymptote. So we can be able to sketch this graph. I just want to erase everything here. Erase everything. I'm referring to what is been written with a pen, not what I typed. So I'm erasing what I wrote. And I want to draw a graph which is a hyperbola graph. I have the y-axis, I have the x-axis. Let us show the asymptote. We are sketching a graph. I said the asymptote, 1, 2. I said the y-asymptote, it is 2. What is the x-asymptote? 3. 1, 2, 3. Show it dotted line. Now you see that actually the asymptote, this dotted line asymptote, they divided our graph, they give us 4 quadrants. They give us 4 quadrants. We've got 1, 2, 3, 4. And you look at A, this is f of x equals to 4. A, this is what I'm referring to when I say A. A is greater than 0. I expect the graph to be in the first and in the third quadrant. That's where the graph is going to be. Okay, but now I know the x-intercept is 1. It means the graph will pass here, where x is 1. And I know the y-intercept. I said it's 2/3, which is 0,67. So it will pass somewhere here. Let me put 0,67 underneath 1. It will pass here. 0,67. So the graph goes like this. Then the other one, you just go and put it in the first quadrant. You say f of x. Then you have sketched the graph. Let me see. You see here, I've sketched it. The y-intercept is 1, so its graph is passing at 1. The y-intercept is 0,67. The graph is passing at 0,67. The asymptotes are shown, the vertical asymptote, the horizontal asymptote. This is the complete sketch of the hyperbola graph. So hopefully, guys, you will be able to sketch the hyperbola function. They can ask you in the exam, Anytime it's tea time, they say to you, sketch the hyperbola function. Hopefully you will be able to sketch the hyperbola function. Go through this video lesson. Make sure that you understand everything on how to sketch the hyperbola function. We will meet next time. God bless you. God keep you safe. Thank you so much. Great stuff. Keep visiting Academic World by Paternity L, where we deal with mathematics. Thank you so much. I have to end.